Ranak everybody, we have those comment, it's very important, and it's about how to create the different type of mesh elements on the one task, on the one problem. Because the main option which we have in Ansys Mechanical creates the possibility to change the type of the element order, but do it for all our task, for all our problem. And in my previous video, I create a task when we have not only different type of elements, hexa and tetra, in the same model, but also some of these objects have the quadratic element, the second order, means with mid-side nodes, and some of these bodies have the linear mesh with first order with dropped mid-side nodes. So how it is possible and how it can be done? The answer is very simple, but first let's talk shortly about the theory. So when we select the mesh in our outline of Ansys Mechanical, we can take a look to the property. Some of this property is read-only and can be used for obtaining the statistics. For example, this one generates information about the node and element number, which sometimes can be useful, but some of these preferences is very important because they affect and influence to our mesh of our wall model. And the main two preferences here is physics preference and element order. Element order in most cases is program controlled, and program controlled means that we take it from these physics preferences and now it's mechanical. There are several types of these preferences: mechanical, nonlinear mechanical, electromagnetic, CFD, explicit, and so on. It can depend from your version of Ansys. So the main difference which we obtain from this version is the element order and some important preferences to create the mesh. For example, for mechanical task, we have solid bodies which will be meshed with second order element, with quadratic element, with mid-sides. And for explicit, we can use only first order element, so it's linear. But also these wizards, these type of defaults, change not only the element order, but the view of our mesh. For example, mechanical produce mesh which can be solved in the fastest way that we can. For example, minimum number of elements with some additions in the places with high curvature and with some proximity and so on. If we use the preferences for nonlinear mechanics, we need to obtain the better mesh, especially with smoother transition from the small elements to big elements, with better element quality and so on. If we use the explicit, for example, variance, we need to obtain the regular mesh with almost identical sizes, and all these elements must to be the linear, not non-linear, not quadratic. So it can be checked in very simple way by selecting tools of selecting nodes, and when we now try to select by holding a left button the elements, we can see that we have the nodes only in the corner of any of these elements. Something like that. If we if we return to mechanical, we obtain less number of elements, but the number of nodes will be something like the same, because we have, as you can see, the mid-side nodes, and it's true for all parts which we have. So this is our mid-side nodes. And as you can see, the one option change the number of nodes and the element order. You can change it despite all this physics preference by the element order. It's enough to change the program controlled to, for example, linear for now, because it's already quadratic. So we select the linear one, and we obtain almost the same mesh, which look almost the same, with the big elements and so on, but with some difference. And now all these mesh will have only nodes on the corner, and it's true for all objects in our model. And that's the case. That's the question. So we can change it. Why it can be important? Because for some cases, the preferences for CFD, for example, or for explicit can be very useful, can take the minimum hour changes to the mesh, but in reasons that we doesn't solve, for example, explicit task, we solve mechanical task, we need to use the quadratic element instead. So we can choose the main options for the element quality, for the transitions of mesh and so on with the physics preferences, but use additional change of element order. But it's for all parts, for all bodies in the same time, and it can change by the tools from the mesh toolbar. When we select the mesh on the outline, and when we select context mesh from the ribbon, context tools. So we have a lot of different tools which can edit the result of our mesh. We can change the sizing for bodies, for faces, for curves and edges, and even for some regions around the point. We can create the mesh on different faces of our body if they have the same geometry, to create a corresponding mesh which match from the both sides. It's very important for circular symmetry, for example. We can create a face meshing with the regular mesh on some faces. We can do a lot of things, even the merge of the nodes and so on. And we can change the method of meshing of our body. In most cases, when we select the hour method, we change those type of preferences. So we change the type of forma of our element. In most cases, automatic do chooses for their own and choose the variant which is mostly simple for them. In most cases, it's tetrahedrons. The tetrahedrons say that no matter what we choose, we need to obtain only tetras element. And hex dominant, sweep, multizone have the other options. Hex dominant creates mostly hex mesh. Sweep and multizone can create the prismatic elements, and can create the hex element, and so on. So this changes the form of our element, but also you can find here element order options. And by the default, it uses the global settings. So no matter what we choose in the method of our mesh, we obtain the same type of elements for the body, for the part. It's very important, but we will talk about this later. But we can change it. And for example, now we have mechanical options, the linear element order. So let's, for this body, which we select, change the element order to quadratic. And for example, for this body, let's change the option for the linear, no matter what we choose previously. So when we create now those elements, those objects, will have the linear mesh. Like it look on the global preferences, and like it look on our additional preferences. But this one, the gray one, have mid-side nodes, so it have quadratic elements or second order, or in some terms even high quality. And even if we change here from the linear on the global to the quadratic and recalculate our mesh, this object will have the quadratic element, but this will have quadratic elements, but those objects have only linear without mid-sides, as we create here. And for this body, we doesn't create any additional preferences, so it uses global settings. That's how you can change the type of element, the element order for some bodies in your solution. You need to understand also some limitations. If you have the multi-body part, it will be a very bad solution if you create some bodies with the second order element and some bodies with the first order element, because some of mid-sides on the border between those two bodies will partially fly in the air, fly in the space. They connected only to one body and for elements from the one body, and not connected to the second one. So it will be big number of errors and in calculation and so on. So please don't do that. If you have additional question, please write a comment and I will try to answer. Also, you can support this channel by those QR code. Like, subscribe, and comment. See you later.